Now, in this part of the session, we're going to talk about another method to find the limit of a function of more than one variable. If the limit along different paths are equal, we said we cannot guarantee existence of the limit, so I need a more general formula or a rule to give me a conclusive okay. Now let's start. Okay, from the word polar method, actually, the main idea here of this problem, okay, that I'm gonna transform the problem, the, the function from xy from the Cartesian coordinate using the Cartesian coordinates to a function in r and theta, which we call it the polar which we call the polar coordinate. If I'm gonna make changes of a variables from the Cartesian to the polar, let's revise كده the transformation relations. If I have, this is the xy plane where I have plotted my points, okay, and I need at any point defined by the Cartesian x and y, I need to define it by the r's and theta. When we say r, actually r, it is the distance from the point, from the origin to the point. Yeah, but this distance actually is equal to, is given definitely in terms of x and y. So I have these relations that r is equal to the square root of x squared plus y squared, right? Or transform the other way around. I have each x is equal to r cosine theta, where theta is the angle from the positive direction of the x-axis, okay, and y is r sine theta, it is the opposite direction. يبقى بالتالي I either work with these two formulas, remove every x and y with these relations, or the other way around. I know that the r is the square root of x squared y squared, and the theta also I could have a formula in terms of x and y, it is tan inverse y over x, okay. If I know this information from before, the relation between x, y and r with theta. Now I need to use this relation actually to find limits. We will see why this is the case. This will give me a really good but it's not usually preferable to start with this because it includes sometimes lots of algebraic manipulation and jobs to do. Sometimes it's not easy to derive also or arrive at a conclusion. So if the simple cases gave me simple methods, then I'll go with the other methods. If not, then I'll go with this polar method. Now let's do the job. Now I know that I want to find the limit of this function as xy approaches 0, 0. Now let's do the job. طبعا by simple substitution, let's check it. This is 0 over 0, won't do. There is no factorization here possible. Then I'll have, let's go with the polar method. If I'm gonna use the polar method to try to evaluate a value for this, and we will discuss the method through this example. First thing, we'll substitute with these relations. So every x will be r cosine theta. يبقى r x cube is r cubed cosine cubed theta, plus every y is r sine, يبقى r cubed sine cubed. Okay, we're substituting with the transformation relation. So x squared will be r squared cosine squared theta plus y squared, which is r squared sine squared theta. Okay, now I need to put the limiting rule. Limit xy tends to 0, 0. Definitely now I don't have any x's and y's in my expression, so definitely I have to work with r and theta. Let's look at the geometric meaning of this problem. Now I'm standing at a point. Now what is the point that we're dealing with here? The center is the point 0, 0. I want to approach this point, and I'm saying I need to approach from all directions. What is better approaching than a circle from within this point? But this is the generalized form to approach with. طب if I'm standing at any point here, x and y, and I'm approaching this point 0, 0. Now I want to deal with r with theta. What's happening to r and theta? What is the value of r as x approaches 0? This is the question now. As x tends to 0 and y tends to 0, I need to know what about the r's and theta. Actually, the r will be tending also to 0 لأنه معنى أن I'm approaching the point 0, 0. This means that the distance r, where I know that r is equal to square root of x squared plus y squared, then definitely r will go to 0 as x and y tends to 0. But what about the theta? Actually, the theta, I'm standing here, say مثلا I'm standing at a value theta. Do I care? I already have the theta is the r tends to 0. So actually the theta won't approach 0. And now all I know about this, when the x and y is limiting, I know that the theta will be any value in this whole circle around the origin. The theta will range from 0 to 2 pi. But actually the theta won't have a limiting value as x and y tends to 0, but all I know that the theta is takes any value from 0 to 2 pi. Okay, so I'll write it here beside my expression, and the limiting expression, and I will only have the limiting value for the r. This must be really understood. When you transform from xy to r theta, the limits are transformed to r tends to 0 and the theta from 0 to 2 pi. Now it should be clear, the idea now is, if I got the limiting value and it turned out to be function of theta, then definitely the limit depends on the angle on which you're standing on. Okay, if it depends on theta, then you will have different values, and the theta changes from 0 to 2 pi. Then the limit theta does not exist. This is the main concern. If I finished the job and I ended up with a theta variable inside my limits, then it does not exist. If it turned out to be the limit as a constant, otherwise if it turned out to be a constant independent of theta and it has a real number, finite value, okay, then I'll have a limit, and the limit then I say that the limit exists, and this limit definitely is this L, okay, and is equal to this L. I don't need to do paths here. Let's do by the job. Now we did half of the job. We substituted with the polar relations. We need to simplify tani. Before substituting, I need to simplify first to be able to arrive to a conclusion. Now simplify by r cubed, common factor 4. If I have r cubed, I'll open the bracket, cosine cubed theta plus sine cubed theta over r squared, common factor, and I end up with cosine squared plus sine squared. Now we need some trigonometric relations to simplify further. Definitely for the limit r tends to 0. These will cancel out. If I end up with limit r tends to 0 of r times a bracket, so on this bracket in the denominator is from my trigonometric relations equal to 1. Above I have cosine cubed theta plus sine cubed theta. Can I directly arrive at a conclusion? Don't forget yet they were theta from 0 to 2 pi. Now I can take the limits, okay? The limit r times a bracket, okay, a function of theta, and r tends to 0, so I have a 0 times this bracket, which could have any value, say مثلا I have a value m, okay. When can I say that 0 times a value is equal to 0? Should do everything mathematically correct. I must be sure doing everything. This is equal to 0, yes, only if I have a condition here, only if m is bounded, okay? Only if the value of this bracket is bounded for all theta. It's obvious that this bracket is simply bounded because I know that the cosine theta is bounded from negative 1 to 1, and I know that the sine is bounded from negative 1 to 1. and I know that the cubes also are bounded, so I know that the addition also of these two formulas also will be bounded from -2 to 2 maximum. Okay, so then I know that these yes are bounded, and I'll just write this verification. I need to verify that m is bounded. Okay, then I need best to write that this bracket sine cubed theta plus cosine cubed theta definitely is bounded above from 2 and below from -2. Any bound doesn't necessarily to be tight. Any bound will do. All I care about are these bounds finite or not finite. Okay, then yes, I'm sure that this is equal to 0. Okay, if بالتالي the limit is equal to 0. Did it turn out to be a function of theta? No. Is it an infinite value? No. Then the limit exists. But this is my conclusion. But the limit exists, and it is equal to 0. Okay, now we have already used some of the rules of limits, and we know the rules of limits for one variable. Actually they come with me I could be used here with functions of two variables: the sum rule, the difference rule, the product rule if I multiply by a constant, and the quotient rule and the power rule. Please revise all of these rules and understand what the concepts. The main condition here, don't forget that if the limits exist, بمعنى if the limits are real numbers, then these rules applies. If not, they do not apply. One of these cases here, if L and M turned out to be negative and negative, can I say that the limit exists and is equal to infinity? Here actually this is undefined, and I need to do some other rules. Okay, also here when I say L and M, a condition that M is not equal to 0. Okay, but these rules applies when I have a finite values. Okay, these can be useful in problems. Now the other concept of our lecture is about continuity. We need to check where the function f is continuous or not continuous. From a function of one variable f of x at a point A, do we know that the function is continuous at this point if this condition is satisfied? Actually, this tells me three things. This tells me, first of all, that the function is defined. As long as I wrote f(a), this means that the function is defined. The next thing tells me that the limit x tends to f of x exists, then the limit a exists, which I called it before al. But the function is defined and it has the value fa, the limit exists, and the third thing that these two are equal. The two sides of this expression are equal. In other words, the function value is equal to the limiting a value. Actually, this is clear also from figure. Here the limits obviously exist when I'm approaching from different directions, from a minus to a plus. I obtain the limit L, okay, and the function value f of a actually is equal to the limiting value. The other cases will look like this. Say مثلا one of these conditions is not satisfied. Say مثلا I have this function like this, something like this. This is مثلا the function sine x over x. I know that x is equal to 0 is not in the domain of this function. Okay, so sine x over x, the limit actually exists, and the limit is equal to the limit is equal to 1. Okay, so what about the function value? What about the function at 0? Actually 0 is not a point in the domain, so the function is not defined. But f and 0 is not defined. But that's why one of the conditions is not satisfied. But definitely the function f of x, which is sine x over x, actually is discontinuous or is not continuous at x is equal to 0. Okay, but one of the conditions is not satisfied. Another case, say مثلا I have a problem, something like this. Let's take the same problem here. وبعدين جيت قلت لك I told you that I have the function is equal to here under x is equal to 0. This is the function sine x over x. What if I give you the function defined like this, sine x over x, and here I have a 0. at x is equal to 0, and here at x is not equal to 0. This, my function is defined piecewise into pieces like this. Is the function continuous at 0? You're gonna say I have a limit, and this limit as x tends to 0 is equal to 1. And when you solve limit sine x over x as x tends to 0, this will give you a 1. This is your limit. You know that the function is defined at 0. You're going to take it from the function definition, and f at 0 is equal to 0. This is given. This is the function at 0. Now you have the case where the limit is not equal to the function value. So definitely the function is not continuous. Even the function برضو is not continuous and x is equal to 0. Okay, this is the another case. Got the idea? يبقى بالتالي what is the third case? هنا function was not defined. هنا the two sides are not equal. So I could have the limit does not exist. يعني I could have a function that looks like this. مثلا the one we took before here, this is y is equal to x, and this is y is equal to x plus 1. Definitely the function and x is equal to 0 is not defined. But this function f of x which is defined by x plus 1 and x for x less than 0, x greater than 0, here the limit does not exist. Okay, بالتالي this function is not continuous. Also infinite functions are not continuous at the point the f of x is equal to 1 over x at 0. This function actually does not have a limit, and it is discontinuous at 0. Okay, the same will go with us in functions of more than one variable. Same idea. We have the same definition for continuity of a function at a point. This time my point is the point AB, and I write it like this. The function is continuous if this is satisfied. Also, this is considered as three cases. The limit exists. The function at A or B is equal to the limiting value. If both of them are equal to each other, then it is continuous at this point. Okay. In general, actually, we don't need to do this job for all problems. Most problems actually that we are dealing with actually are simple functions that are built from our variables, independent variables, using addition, subtraction, multiplication, division, exponential. Yani most of the problems actually are this type of problems. Okay, so if I know that my problem is a continuous function, I can claim that it is continuous, and the region of continuity actually, the region that the function is continuous at, actually will be my domain. Okay, if my function is a simple function like these functions, the region of continuity actually is the domain of the function. All I have to do is get the domain of f. First step, get the domain of the f. Okay, and then say that this is the region of continuity. Okay, from theorem. If I'm gonna use this, repeat this wherever you want to use it in your problems, as we'll see. When am I gonna use this definition? Actually, when I'm checking a specific point and if there is confusion, there is not assurance that the function is defined at this point, so I'll have to do with the limits. Okay, such as this example. So if I have such problem that define piecewise continuous, and I need to find if the function is continuous and where the set of points at which it's continuous. I'm looking for the region of continuous set of continuous points, the set of points at which the function is continuous. So actually, when I look at the first part of the problem, x squared y cubed over 8x squared plus y squared, actually this function, this is defined for all xy not equal to 0. But on its own, this function is continuous. This is a rational function defined from a multiplication, addition of my variables x and y. This function is continuous in its domain. Okay, what is the domain here? Which is the point r minus the point 0, 0. I'm talking about the first part of the function. So why? From theorem. Okay, I'll write the same sentences written before. But what about the second part? Actually, the function is defined at 0, 0 with the value 1. Then now I need to check. يبقى طبعا 1 this is a constant at this point, but I need really to check بقى continuity فين. I know that it is continuous everywhere, but I don't know continuity at the point 0, 0. يبقى I need to do the job of the limits only for such part. Okay, so to check the continuity at 0, 0, first of all I must find the limit. Okay, and then I'll find the function a and compare it to the function value. So the limit actually the function limit as x or y tends to 0, 0. I'll go with this one because I need to, for points close to the points. I cannot take a 1 and say this is the limit, this is the function value. So I'll take the first part of the problem, x squared y cubed over 8x x power 2 y squared. Now if I did the job here using polar immediately, let's start with the polar, okay, method. Then I'll transform to the polar coordinates. X تبقى r squared cosine squared theta, y cubed will be r cubed sine cubed theta over 8 r squared cosine squared theta plus r squared sine squared theta. All I'm doing is substituting with the values. Limit as r tends to 0 for theta changes from 0 to 2 pi. So simplify, I'll end up with, we have here هنا كده r squared r power 5 على r which is r cubed times the bracket cosine squared plus theta plus sine cubed sine cubed theta over 8 cosine squared theta plus sine squared theta. Now this actually will never, for theta from 0 to pi, actually it is bounded and it will never equal to it is not equal to 0. It will never go to 0, the denominator. The numerator actually is a finite value and it is bounded between 1 and -1. Then I'll claim that this bracket actually is bounded for values of theta from 0 to 2 pi. If you want to do it specifically, you say cosine squared theta is bounded from 0 to 1, okay, and then sine cubed not multiplied by the sine cubed cosine squared theta will be bounded from -1 to 1, and then dividing both sides by 8 over cosine squared theta plus sine squared, where this is never equal to 0, it will be bounded by a real number. Then this definitely is bounded from above and bounded from below, so this is a finitely bounded a term. So now I can take the limits carefully, but I'll say r tends to 0 times a bounded value which will be equal to 0. So the limit here actually is equal to 0. Okay, now I found a value for the limit of this function. This is the first step. What is the second step? I know that the function at 0, 0 from the definition, here again I hold the definition of the problem, the function at 0, 0 is equal to 1. Now I have a value for the function. From the definition it's equal to 1 and the limit is equal to 0. Definitely both of these are not equal, so I'll conclude that the limit is not equal to the function value. Then the function limit exists and it is equal to 0, but what I know now that the function f of x or y is not continuous at the point 0, 0. In other words, I know that the function is continuous everywhere for all x and y, يعني في xy plane, for all x وy's في ال xy plane مش كده except ايه except at 0 0 يبقى هي continuous everywhere except at the zeros. Okay, if we have about 3 variables higher dimension, actually it's the same job, taking care that the point approaches the triple order xyz here, and I'm trying to find a limit. طبعا by simple substitution we're gonna find 0 a and 0. We can also do the paths method here. We can do the paths method for such problem and check different paths. X is a 0, y is a 0, or whatever. If we took paths, say مثلا the simplest path, if I'm moving along the x-axis, then I have the y's and z's are equal to 0. Okay, this is the first path, and I'll end up with the limit of x squared over a x squared. Simplify, I'm gonna end up with the 1. Okay, the 1 as x tends to 0. If I took another path, say مثلا let's take the z يعني along the z axis, then I'll take the y is a 0 and the x is a 0, then I'll end up with the limit of 3z squared over z squared. Simplifying, I'll end up with 3. So it's obvious from here that I directly arrive to a conclusion that I have a limit which is equal to 1 and another limit which is equal to 3. خلاص, I took different paths and I obtained different values. So خلاص, I have a conclusion. I could claim that the limit does not exist. I conclude this here. Okay, but the limit at the point 0 0 0 actually does not exist. Thank you.